Algebraic expressions. In this lesson, we discuss algebraic expressions. Now, in one previous lesson, we discussed the different terms that are used to describe expressions in algebra. Now, in this lesson, we expand our understanding of algebra in what is called algebraic expressions. We will also, with the time, look at algebraic language, the words, the diagrams, and also the expressions. Now, when we talk of algebraic expressions, we are simply referring to, a description of a set of operations. Could be addition of something to another, could be multiplication of one quantity and the other, could be subtraction, or could be division. So this description of a set of operations that are to be done in certain order is what we call algebraic expressions. Okay, so you think of a set of operation, could be adding 1 to 2, could be multiplying 3 and 1, could be like dividing 6 by 8, something like that. That set of operation that are to be done in a certain order is what we call algebraic, expressions. In this chapter, then, we will study, or you will learn how to specify a different set of operations that will produce the same result as the given set of operations. Okay, so we will be having a set of operations that we are going to be dealing with, and specifically you will learn to specify a different set of operations that will produce the same results as the given set of operation. Now, all these definitions will make sense in a minute as we will begin to look at some practical questions. Now, two different expressions that produce the same result are called equivalent expressions. So you would think of two expressions that produce the same result, and we will be calling them algebraic, or equivalent expressions. We will also be looking at some of those expressions that produce the same result. So now, precisely when we talk of algebraic languages, the language which is used to describe, operations in algebra, well, the languages include words. We can use expressions and sometimes diagrams. Now, when you look at this question, which is requiring us to complete this table, now notice in the table we have got words. We also have flow diagrams. Then we have got expressions, which we call algebraic expressions. So now here is one case that multiply any number. Now, since the number is not given, we would like to represent it with, say, a letter X. And so when they are saying multiply a number by 5, that means you think of any number X, multiply it by 5, and then subtract 3 from the answer. So now when you get a number and you multiply it with a 5, what you get later is 5x, which is the result. Now, when you are required, to again take away or subtract some quantity, in this case 3, from the answer, then you will be having 5 times x minus 3. Now, we would also look at some other numbers shortly. Now, when you look at, for example, the second part of this same question, well, here we have been given that add 5 to a number and then multiply the answer by 3. Okay, so in the first box we add 5. Then what we do after adding 5 to the number, we will get the answer. Now, the answer that we get is what we are supposed to multiply by 3. So in a very simplified way, we are supposed to think of any number. That number, to it we add 5. So what have we got? Well, we have got x plus 5. And so this x plus 5 that we have got, we are supposed to multiply it with 5. Now notice that putting it inside the bracket makes it easy, because this time we have got the result. This result that we have got is not one number. This result we have is a combination of a number and the letter that we have chosen. And so if we put it inside the bracket, it's going to be a lot easier to see how you can multiply. And that way, the rule of algebra will not have been broken. And so from here, we then do what? We multiply by 3. That would be the solution to what? To this first question, this first practice question, part A. Now, the next question is not having wordly expression. It's simply having a flow diagram. And then we are supposed to get from it an expression. So you see, here we have it. It's like, well, think of a number, or simply subtract 3 from a number. Okay, not to a number, but from a number. So subtract 3 from a number and then multiply the answer by 5. Yes, that is the wording. That is how the wording would be. So the wording would be subtract 3 from a number. Okay, subtract 3 from a number. So we would have subtract, which is given here. And multiply the answer by 5. Okay. Answer. So what would the expression be then? Well, the expression would be thinking of a number first. When you think of a number like x, so we are supposed to subtract 3 from this number. And so when we subtract 3 from the number, what we get is what? X minus 3. Now it makes sense if we put it inside the bracket. And then now after getting this, we are supposed to multiply this by what? By 5. And when we multiply it by 5, what we get is the expression. Okay, now notice that this expression can also be written with 5 coming first. So it will then be 5. Okay, it's what? It's x minus 3. And so this way we have 5 into x minus 3. Now notice that in the first expression, we could have done the same. Well, we will be having 3 times, okay, the quantity what? The quantity x plus 5. That is what we would get. Well, we could go ahead and look at part C. Now notice that in part C, we have the expression. And what's the expression? Well, the expression given is 3 times 2x plus 3. Well, let's put it here. We have been given the expression, which is what? 3 times 2x This is the expression that we have given. And now what are we supposed to do? Well, we are supposed to get the expression in flow diagrams, then later words. We could start with the words. What are we supposed to get from here? Well, what we have been given is that, notice that when you are required, for example, to express this or to say this in words, the first step is to look for the unknown, the letter. How is it attached to a number? What number is the letter attached to? So now when you look at that, you notice the number attached to the letter is 2 and the letter is x. So we could think of 2 and x, and this between 2 and x we have times. So the first thing would then be multiply a number by 2. Any number, which in this case is chosen as x. So multiply a number by 2 and then add 3 to the answer. Then the result, multiply it by 3. You see? So the first thing in this case would be multiply a number by 2. 2. Well, just to for you to see, this is what we have when we multiply a number by 2. After that, the next thing we are supposed to do is to add 3 to that to what we have got. Then that would be like, well, add 3 to the answer. Okay, so the next thing is add 3. Yes. Well, what do we get when we add 3 to the answer? Well, what we are going to get is going to be 2x plus what? And the next thing to add there is multiply the result by 3. Okay. Multiply the result by 3. The next step, that is multiply the result by 3. Result by 3. Yes, if you do that, then you're going to have in total 3 times what? Times 2x plus what? Plus 3. That is going to be what? Your result. Now, notice that there are times, okay? There are times when we are required to evaluate this. In most parts, or most of the time, you will be having to deal with a question which is already summarized for you. You don't have to go through the process of creating or forming expressions from algebraic what? Words. You only have to evaluate what you have been given. And because of that, well, we could go ahead to evaluation. So let's see evaluation. That is evaluation. So to evaluate is like to find the value of some given expression using the given information. So if that is what we have to do, then we now have to look for what we have been given here. So what we have been given is that we have been given the value of x. What are we supposed to do with the value of x? Well, it's supposed to help us in finding the value of the expressions. The question is, evaluate each of these expressions for x equal to 10. So how do you evaluate this? Well, let's say the first question is 2.1. What we have been given is what? Is 200 minus what? Minus 5x. So 200 minus 5x is what we have been given. So how do you evaluate this? Well, now notice if you were, for example, to change this in words, it would be kind of quite long. Okay. This time it is started with a 200, then you have a minus, then you have a 5x. You know, you could still have it in words, but this time we are just supposed to find the value of these expressions. What do we have? Well, we do have the value of x. X has been given as what? As 10. So what would be the value of this? Well, the value of this expression would be 200 minus 5 times x. Notice that x has been given, which is 10. So from there, we can have 200 minus 50, and this is to 150. That is how you evaluate the value of the expression. Now, in the second question, we have been given that 200 minus 5 x is outside the bracket this time. Question 2.2. Notice that if for some reason you are supposed to deal with a quantity which is inside the bracket, then it is safer to first deal with what is inside the bracket before you expand everything. It's much safer. And what would that give us? Well, this one would give us 200 minus 5. And 200 minus 5 gives us a value of what? 195. Yes. X. That is what we get when we simplify what is inside the bracket. Now, the next thing that we want to deal with at this point in time is to substitute 10 for x, because we have been given that x is what? Is 10. 195. And we are get later is going to be 1950. Yes, that is how we would evaluate question 2 part 2. Now for question 2 part 3, that is 2.3, what we have been required, or what we are required to do is to evaluate 5x plus what? Now, because we are required to evaluate 5x plus 40, what we do in this case, we don't have a bracket, we don't have nothing. We do have the value of x, and so because of that, that's what we are going to use. So we have 5, and to it we attach what? 10. That is 5 times 10, since x is given as 10. Notice that 5x is the same as 5 times x, and so 5x or 5 times x, if x is 10, will then be 5 times 10. And remember, to it we have to add what? 40. And so we can go ahead to simplify this. That way we get 50 for 10 times x, and we add a 40. In total, that will give us a 90. Yes, that is 2.3. Now in the next question, which is what? Which is 2.4, we have been given that expression this time is 5. This 5 is used to multiply what? X. Okay. X plus 40. Now notice how they look so similar. When you look at 2.3, which is 5x plus 40, and then when you look at 2.4, which is 5 times then x plus 40. Okay. Now, how can we simplify this? Well, we have already seen earlier on that once you have a bracket in an expression, in an algebraic expression, the first thing or the safest thing to do is first to evaluate or you deal with what is inside the bracket before anything else comes in. And for this reason, we are going to keep 5 out. We leave it outside the way it was initially. Then what is inside the bracket, which is x, will now be 10 since x has been given as 10, and to it we add a 40. Now that way, it will be not easy for us to see how to deal with the quantities inside the bracket. Because of that, we will then have 5, and inside the bracket we will have what? We will have a 50. That is very much like 5 times 50. And so we can simplify that to 250. Now, the next thing that we have to deal with is 2.5. And question 2.5 is requiring us to simplify. Well, we have to simplify 40 plus 5x. Yes, 40 plus 5x. So the question is, how do we deal with this? Well, dealing with this is not going to be difficult. Reason being, the quantities don't have any bracket. They are like in open space. And because that is how they are, simplifying it will be easy. Where there is x, you just put what? You put a 10. So 5x will now have 5 times 10. Not 5 tens, but 5 times 10. Because 5x is the same as 5 times x. From here, we can go ahead with the simplification. So that we have a 40 plus what? A 50. And this way, we get what? We get. Notice that we first deal with the multiplication before we add it to 40. So that we get a 90. That is the simple rule that we do what? That we follow. Now, the next question is 2.6. Question 2.6. What we are supposed to do is also to evaluate. This time we have what? We have a 5x. We also have a 5, but this 5 is used to multiply what? A 40. Well, the question is, how do we simplify that? To simplify this, we write 5x. Okay. Yes. Why 200? It's because 5 times 200 times 40 is 200. Now, we decided first to deal with multiplication before bringing in the value of x in the substitution. We did that because that way we are much safer. You know, we're taking one step at a time, which is very important when you are handling, when you're handling evaluation or simplifying things in mathematics. At this stage, we can move on to the next step. That is, we can now substitute 10 for x. So that instead of 5x, we now have 5 times 10. And we add 200. So this way, we deal with 5 times 10, and we get 50. We add 200. Now that should simplify to 250. That is how you would handle question what? 2.6. Now, see if we do have one more question. Well, yes, we do have one other question before you can for yourself have what? A class activity. Well, what is this question all about? Now, notice that as we will be carrying on with our discussion of algebraic expressions, okay? As we will be carrying on with our discussion of algebraic expressions, we will sometime be required to deal, with some definitions of terms. Terms like variables, terms like for example, what we have been seeing here, you have x, you have numbers, x and numbers x. How do we call this x? We were saying choose a number and to it add this, or think of a number, or multiply a number by that. So what is this number that you are using? Are we simply going to call it number? No. There is how we describe this. The x, for example, that we have been talking about a lot is called a variable. This x can take on any value. It can take on 10. It can take on 5. It can take on -3. It can take on any number. The number can change. The number can vary. And because of that, x is called a variable. Now, all these other quantities, as will be required, we are going to discuss it in this question. So, well, we have been given the following expressions. Well, we could put down the expression. Okay, we've been given some expressions. So let's have it here as expressions. The expression given is what? The expression given is 3x power 5. Okay, we have 3x 5 minus 4x power 4 minus 4x x power 4, that is 4x exponent 4. Then the next thing that we have is 8x squared, that is 8x squared. This 8x squared, we also have 10x. And finally, all right, 10x is added. Finally, we have 11. We can go ahead to answer these questions. Given here is question 1. That what is the degree of this expression? Now, the term or the word degree of an expression. Remember, this is an algebraic expression. So we say the word degree of an expression means the highest exponent of the letter in question, or like the highest exponent of the letter x in this expression. So what is the highest exponent? The highest exponent is 5. And so we say the degree is 5, okay? The degree of this expression is 5. Yes, that is the degree of the expression is what? Is 5. The next thing that we also want to deal with is this question, part B. Now in part B, we are supposed to find the coefficient of x power 4. What does it mean, coefficient? Now notice that these expressions we are talking about, the algebraic expressions, there are so many occasions where you will have a number multiplying this letter. So this number which is multiplying this letter is called the coefficient of that letter. For example, in the expressions that we have been looking at previously, we were shown or we were required to multiply a number by 3. So if you are required to multiply a number by 3 or say by 2, that means you will have 2 times that number. And 2 times that number would give you 2 of that number, or simply 2x. In this case, 2 is called the coefficient. And in the same way, when we look at this question here, x exponent 4, x with exponent 4 or x power 4 has got a number in front of it, and that number is what? Negative 4. And so how do you call this negative 4? Well, we say the coefficient of x squared is negative 4. Okay, so coefficient x squared, coefficient of x 4 is what? Is negative 4. Yes. Now the next thing we want to look at is question 2, part C. Part C is asking for, yes, a quantity here, that are there any like terms in the expression? Now, like terms or the phrase like terms is used to describe quantities that look like, in the sense that if one quantity here has got x, the other one also got x. If this one has got y, the other one has got y. If this one is 1, that one may be 5. If there is no x attached to one quantity, and there is another quantity, x is not attached to it, we say they are like terms. Why? Because they don't have any function x attached to them. And because of that, we call them like terms. And so, do we have any like terms in the expression? No, we don't have any quantity which is called, or quantities that are known as like terms. We don't, we say no. Then the next part, what? The next part of this question is part D. How many terms are in the expression? Now notice that the word terms is used to refer to these expressions like 3x exponent 5 or 3x power 5. It's called a term. Also what? Negative 4x power 4 is called a term, just like 8x squared, and also 10x, just like negative 10. All these ones are separate terms. And by the way, you could count this being the first term, this is the second term, this is the third term, this is the fourth term, and also the fifth term. And so when you look at question 2 part D specifically, they're asking for how many terms. So it's like counting. We count 1, 2, 3, 4, 5. That gives us 5 terms. We write it as 5. Okay, or we say the number of terms is 5. Now the next we want to look at is question 2. So how do we handle that? Well, part E is asking for the value of the constant. What is the value of the constant? Now, notice that in an expression like this that we just wrote, the constant is this term inside the expression where there is no x. So if we can find a term in the expression and there is no x attached to the term or multiplying the term, then this term is called a constant. what it does means is that this term does not change, or it will not change. You know, the terms where you find x, they can change. You know, they can change. Like they vary depending on x. Like if x is 1, that quantity is multiplied by 1. If x is 2, the quantity is multiplied by 2. And for x being 3, the quantity is multiplied by 3. And so for this question, the value of the constant is this, which is what? Negative 11. Now, lastly, which is what? We are supposed to do what? We are supposed to find the value of the expression if x is given. Okay? How do you get the value of the expression? X has been given. So now, since x has been given, what we are going to do is everywhere where we find x, we do what? We substitute with the given value, which is negative 3. And so, in this expression, which we already have given here, we take it and then we use it. So when we take it and we begin to use it here, where there is, x, 5. Is it? No, negative 3. So like right here, we can do what? We can put negative 3. Inside here, sometimes it helps to be using a graph, rather to be using a box, or rather a bracket. And so if we have something there, we can now put negative 3. And also, we put it here. Okay, we put it inside the bracket. And we would like to call it also negative 3. And now, lastly, we have it out here. This one out. We can also substitute what? The value of x, which is what? Now that way, we can go ahead to find the value of the expression. So now from here, what we want to do is find the value of the expression. And how do you do that? Well, let's get our calculator. This will be a lot easier for us to handle. So here we go. The whole thing in the calculator. So we have 3 times, write this 3 times with exponent of 5. Well, 3 times what? Times negative 3. We close the bracket. Then we have exponent of what? Exponent of 5. Then from that, minus 4 times negative 3. Okay, we close that. 4 times negative 3. I guess that is what I wanted to write. 4 times negative 3. No, I did not write it nicely. Let me do this again. So we'll be having 3. Then we put negative 3. Then we close the bracket. Okay. Well, seems not to be working nicely with our calculator here. This is not supposed to take us too much time. 3 times, then we open a bracket, then we put negative 3. Then we close the bracket, then we put raised to 5. Then, well, this seems not to be giving me what I want. So, how else? How else can we handle this? This would need, this calculator should work. Okay. So one more time, we have 3 times, okay. Then we open a bracket. Minus what? Minus 3. What? Close the bracket. Then we raise this to what? 5. Then say minus, okay, 4. Bracket. In it. Alright, since it's not working with this calculator I'm using, I'm going to use another calculator now, just so I can get the correct value right away without spending much time. So the calculator is still going to be a scientific calculator, but with much more advanced what? Functions. So we do have 3, then bracket, negative 3, we close the bracket, we raise this to what? To power of 5. So we say with the power of 5. Then we move to minus 4 times, that is open bracket, negative 3. We close it, then we raise it to what? To power of 4. Then we say plus 8, then bracket, negative 3, we close it up. Then after negative 3, we say squared or raised to exponent 2. Then to that we add, this time we are adding 10. Okay, we're adding 10, which will later be multiplied with negative 3. Then the result, we later take away 11 from it. That is, from the result, we take away 11. Well, this has been a long one. What has it given us? Well, that's a value of negative 10, rather negative 1000. Yes, this is the final value of what? Of this expression. And from that, we can now say, yeah, we are what? We are done with this type of thing. Now, the next thing is, that is how algebraic expressions are described. Algebraic expressions are described as monomials, binomials, trinomials, and polynomial. So if you find out that there is only one term, remember we had already seen that when we talk of terms, we are referring to specific, a specific expression within an algebraic expression. So when you have only one term as an expression, then that is called a monomial. If you have two terms, then you call them binomial. For three terms, trinomial. And for four terms, we call them polynomial. Now that should lead us, or should at least be good enough for you to go ahead and do this class activity. Here you will complete. Now I will do for you these parts here. Then you can take over from here. You will have to write what the variables are. The variables are these unknown letters that are part of the what? Unknown letters that are part of the expression. So for example, for this expression, the unknown letter is x and the constant is 10. The coefficient of the second term is 6. Second term, it's 6. Because the first term is x squared, the second term is 6x, the third term is 10. How many terms? 1, 2, 3. So because there are 3, they are trinomials. The what? The variable is represented by x. The constant is 10, and the coefficient of the second term is 6. Then we move to the second one. The second one has got how many terms? 1, 2, 3. Also trinomial. Then this one has 1, 2 terms. We call them binomial. And this one is just one term. So we call it a monomial. So that is how we would handle the type of expression. Now, I need you to fill in the value for the variables here, again here, and again here. Then later, get the constants before you can find the coefficient of s squared and what? The coefficient of b power 10. Okay. Also here you are supposed to write down the what? The first term. When you are done with that, the next thing for you to do is what? Is to submit the work. As you submit the work, the next thing is to get it corrected. So we possibly have to continue from that point.